This machine behind me is doing something amazing. It is converting waste plastic into gasoline. That's right. This waste plastic, something we all know and love and hate, into this gasoline, diesel, and kerosene. Now, this could be an absolute game changer, as you can imagine. Plastics as a whole are so amazing, but those same properties make it really hard to recycle. So to see what Petgas is doing, we're here in Mexico to see their novel approach to thermal pyrolysis and how that could be a game changer for the future of plastic waste. So let's figure this out together. I'm Ricky, and this is 2-Bit Vinci.
This video is brought to you by boot.dev. All right, so we've loaded the HDPE and the LDPE and the polypropylene. Next, we have just random trash that isn't shredded that we're gonna put in as well. And by the way, you can see some of this stuff hasn't been washed. There's actually just trash and like food residue, and that's all fine as well. So we'll stick that in and then continue with the process.
All right, so let's talk about the inputs and outputs of the Petgas system. Here, this is shredded LDPE, low density polyethylene. This has been kind of sorted for color, it looks like, and mechanically shredded to make it small and manageable. And this is HDPE, high density polyethylene, again, mechanically shredded from trays and other large plastic bins. Others include polypropylene and polystyrene. Those are the four best ingredients for this system to give you the highest quality of outputs. Now let's start with what comes out. This is what's left in the reactor. So in the very first stage, this is what's left after all the hydrocarbons have been released and gasified through pyrolysis. This is coke. Interestingly, this is actually really high quality coke, and it can be used to line the linings of high temperature furnaces. So this has commercial value. Then in the first stage, we have paraffin. This is wax. And what happens to paraffin when it cools to room temperature? Well, it's solid, just like this here. Again, it has commercial value. Paraffin is used for all sorts of things, sealing, candle making, and so much more. Then the next heaviest element is kerosene, and that's what we have here. This is what comes out in the reactor number 2. From there, we have diesel. This is their diesel equivalent. It comes out at the next stage. Finally, in that last reactor after the chiller, we have gasoline. You can kind of see the differences in viscosity and density. You kind of see that as I shake them around a little. You can just see how much less viscous the gasoline is compared to the kerosene.
So the premise is incredibly appealing. Take mountains of unwanted trash and turn them into valuable fuel. It sounds like the perfect solution. But to really understand the impact of a technology like this, we have to grasp with the sheer scale of the problem we're trying to solve. Globally, we produce over 400 million metric tons of plastic waste every year. That's roughly equivalent to the combined total weight of every single human being on Earth, all 8 billion of us every year. And shockingly, less than 10% of that plastic has ever been recycled. The other 90% is piling up in landfills, in our environment, our oceans, wildlife, and worse, in our bodies. Yeah, you heard that right. A recent study found microplastics in human brain tissue from diseased patients and a possible link to dementia. Now, that's pretty scary. And this is a problem that we have to solve, and companies like Petgas are solving it. We visited one of their pilot plants down in Mexico to see for ourselves what they were up to.
Check this out. It's been a couple of hours, and the system is now in kind of a steady state. Pressure is building here at a healthy level. Again, it's pretty low pressure reaction. Coming across here, this is the temperature of the gas side. So the gas that's going past and continuing on is around 190 degrees. And down here is the liquid paraffin, a little bit cooler, around 140 or so. And then coming across here, that pressure is pretty steady throughout. And temperatures start to drop. You can see that the temperature here is lower. And then finally down here, it's quite a bit lower. And then by the time it goes through this chill bath, it's actually at or, even kind of at room temperature or maybe even below. So at this point, if you look closely, you can see the gas condensing out. If I kind of shake it a little, you can see those ripples. So it's kind of trickling out at this point.
But before we get into that, I have to tell you about our sponsor this week, boot.dev. Boot.dev is the software learning platform I wish I had made. What helps me learn most is having a concrete use case, a thing I'm trying to build. And with boot.dev, you're building a fictional fantasy game called Fantasy Quest. All the lessons build off of this, and it's really immersive and makes you understand why, not just how. Programmers have amazing earning potential. According to Stack Overflow, the median salary for a backend developer in the US in 2024 was over $100,000. You don't just learn languages like Python, but you learn operating systems like Linux, which is critical if you're actually wanting to build and run your code. And you can't forget about Git for source control and managing your code. I've been building a secret website that I'll share with you guys here in a couple months, but trust me, this is an amazing resource for everything you need to know. It's free to create an account, and it's even free to read and watch all the content for all the courses. But a paid account gives you access to all the interactive features that make this so much fun, like Boots, your AI assistant who answers any questions you might have, or your spellbook for quick references to variables and functions. Seriously, if you have ever wanted to learn more about software or are thinking about a new career, go to boot.dev and use my code to get 25% off the entire first year on an annual plan. Links in the description. Huge thanks to boot.dev and you. Now back to the show. There's a key part to this process that's not obvious. You see, the chillers that condense the gasoline can't condense all the gases that form during pyrolysis. So there's this leftover, non-condensable fraction that's made up of propane, butane, and other light gases. So what do you do with it? This is where Petgas system is pretty genius. Thermal pyrolysis is endothermic. It needs lots of heat to run. The guys at Petgas figured, why don't we just take this leftover gas, reroute it back to the furnace and burn it to keep the process running.
All right, so once it reaches 0.5 kilograms of pressure, which the system now has, there's sufficient flow throughout to be able to power it from this final stage of gas. So I'm gonna open this valve. The external gas line is completely shut off, and we are running this entire reaction from the final stage waste gas product from the pyrolysis system. Now, this almost sounds like it's too good to be true, like it's a perpetual energy motion device. It's not, right? Because the plastic that we started with had some level of chemical energy that is now releasing. When all of that is expended and all you're left with is that coke at the bottom, this process will stop. There'll be no energy left. You do need an external source of natural gas or something else for the first hour and a half. And after that, this thing's pretty much self-sustaining. All you need is electricity for the
chiller,
pump, right?
and the dashboard. And that's one of the criterias that helps us be considered a clean technology and a green technology, because you produce more energy than what you need.
But there's a lot more that makes this game-changing. For example, Petgas claims that they produce gasoline with an octane rating above 90 and even as high as 120, which is not only impressive, but it raises a lot of eyebrows. It really does sound too good to be true. So we had to look into this further, and what I found is pretty interesting. First, virtually all the world's fuels produce using catalytic pyrolysis, or more specifically, fluid catalytic cracking. And there's a reason for that. Thermal pyrolysis is notorious for producing a wide mix of hydrocarbon chains, including a lot of heavy waxes and paraffins, resulting in a low-quality, low-octane fuel that needs further catalytic refining. The result is higher operational costs that go through the roof compared to catalytic processes because of higher energy demand and these additional steps. And it's been that way forever. Second, even lab studies struggle to get liquid fuel yields above 70% from waste plastic, with so much of that being low-value gunk. Yet, in addition to the impressive octane numbers, Petgas claims yields of up to 92% condensable fuel from mixed plastic waste, higher even than in controlled lab tests. Most of it high-value gasoline, so you don't need the extra processing steps. Only 5% is heavy waxes like paraffin. They solve the high energy input issue by burning waste gases in the furnace. And the entire system is dead simple, with nothing but steel reactors, piping, a heat pump, and a fuel control systems, so capital costs are really low. You gotta take a step back and realize that's kind of the holy grail of thermal pyrolysis. Something that multi-billion-dollar oil companies like Shell and Exxon haven't figured out in the last 100 years, while a small startup in Mexico seems to have cracked the code.
And it's a very counterintuitive method. For a long time, we have been showing our technology to experts, scientists, different types of environmental advisors, and some of them can't really believe it because it's so simple. And if I could write the formula down for you, you would be like, duh, like how couldn't we have thought of that before? Right. However, that was the brilliance of Petgas to actually bring this technology in a very simple manner, in a very low-tech kind of way.
Yeah.
You don't need plasma converters. You don't need to make all this glam about transforming plastic into fuel. It's a pretty straightforward process, but we got to know how to do it.
If all their claims are as good as they say, this is a total game changer for plastic waste. It'd be a monumental breakthrough for the entire multi-trillion-dollar oil and gas industry. So then, is this just overhyped numbers for marketing, or have they genuinely created a disruptive technology? During our visit, we were able to answer several of these questions ourselves, starting with the quality of the fuel.
Now, this is a octane tester. Now I'm going to test this right here. This was from a previous batch. Let's go ahead and put this in. So it says 93. I saw 92 earlier, 92, 93. That's pretty good. That's higher than in California, the highest octane we can buy. For us in California, octanes are 87, 89, and 91. 91 would be like premium. This is even higher than that. But do remember that, yes, we can recycle all these plastics together. Not all, right? We want to avoid PVC because of the acids and byproducts that are created. And we also want to avoid PET, which is also problematic. The good news is PET can be recycled in other ways. And so if we can tackle the others, right, polystyrene, polypropylene, HDPE, LDPE, that's still a huge win. So yes, it's very flexible, but just like anything else, the variability of your inputs is going to have a huge bearing on the quality of your output. Again, let's remember, this is waste plastic. This was going in landfills or our oceans before, and now we can use it to create products that the entire world is currently using.
We also tested fuels from a previous batch on several vehicles, including a forklift, which I've never driven before.
All right, so that was gasoline. This is diesel. All right, let's try not to spill this time.
And a street sweeper, because how else do you keep your lab clean?
Turns on a dime. Makes a lot of noise doing it. Now, you might not have a forklift or a street sweeper, but this is something that millions of people have around the world, a car. I feel like half of this is just how good can I pour stuff. Obviously, you wouldn't pour gasoline like this, but this is just to prove the point, I think. And instead of piles of plastic that no one wants or needs, we could use it as fuel, which is something that, like it or not, everyone around the world is still using.
So the fuel works. At least some of the numbers check out. We couldn't confirm the final yields because we had to catch a flight and we didn't have time to stick around for the entire process, but we did see a lot of it. And their claims, they might be optimistic, but they are producing a viable product from plastic waste. But this brings us to an important question, the one that many of us should be asking whenever a new tech like this comes along. Should we be doing this? Petgas's marketing, like many plastic to fuel companies, is built around the idea of recycling. But this isn't recycling the way most of us think of it. This isn't plastic, use, and then back to plastic again. This is taking plastic to garbage, to a different supply chain, into fuel, and used there. It's a little bit different. In a circular economy, you turn old plastic bottles back into new plastic bottles, or at least into the chemical building blocks to make new virgin quality plastics. That keeps the carbon locked up in the solid material and reduces the need to extract oil to make new plastics. What we're looking at here is a one-way trip. This process takes plastic, which is essentially sequestered carbon that would remain in that form. Maybe that's not good either, and it converts it back into a fuel that is designed to be burned, immediately releasing that carbon back into the atmosphere as CO2. And this is a fascinating argument, and I'd love to know what you think. Where do you come down on this idea of converting plastic waste, which is a problem, into fuels, which is another problem that we're tackling? We've made videos in the past about companies that are sequestering carbon and carbon capture technologies. Sound off below. And you wouldn't be alone in thinking about this. Organizations like GAIA, the Global Alliance of Incinerator Alternatives, argue that technologies like this are effectively just a fancier, more complex form of incineration. You're still just burning trash. Now, to be fair, it's definitely cleaner than the incinerator and landfill model. And if Petgas can scale, it does tackle at least part of the problems of existing plastic waste, a problem that desperately needs solving. Now, Petgas claims that their fuel burns cleaner because they have a lower sulfur content, which makes sense. Any sulfur was already removed from the crude oil before making the plastic resin. But they also claim to lower greenhouse gas emissions by a minimum of 50% in CO2 and 30% in methane and 60% in nitrogen oxides compared to conventional fuels. To fully understand some of these claims, I think we're gonna have to wait for some third-party analysis and verifications because, it's a complicated process. The fuel that we get from the ground right now, crude oil to convert to gasoline, has all kinds of contaminants, and we remove most of them, but it's not perfect. And depending on where you get your crude oil from, there's different contaminants, different levels of sulfur and other things. So this is not, it's not like there's one chemical makeup that makes something gasoline or diesel or methane. There's a spectrum. Like you draw a line and say, okay, things that fall within this category are gasoline. So that has a little bit of a band to it, and we're gonna have to wait and see just how the numbers play out.
So in a lot of ways, the genius of Petgas' solution is its simplicity. Their thermal pyrolysis approach breaks down plastics into components that we can actually sell and value from. Now there's a million different ways to skin this particular cat. And we've covered companies like Adur that use hydrochemolytic technology, which is a little more sophisticated and returns the plastics back to the virgin stock material to make new plastic. This is different, and we're gonna need a lot of different ways to tackle this. Now, there's no one size fits all to this problem, and this is a big problem. They're gonna have to figure out how input plastics and the composition of PET and HDPE and PPE and everything else is going to affect the final fuels and how they're gonna have to qualify test and everything else. But this is incredibly interesting and game-changing technology. A special thanks to Petgas for hosting us for this day and showing us around their IP. If you want to learn more about the company, we'll have links and documents down below where you can do the research for yourself. But what do you think? How important is plastic waste, plastic recycling, and what do you think about their novel approach to tackling this problem? Sound off below. And until next week, check out this video that we think you're going to love. I'm Ricky from Vinci. Thank you so much for watching.